Okay, so we're going to be working on 2016 paper. So that's the first question. They give you the value of, so they plot P and Q, and they give you the value of S, and they ask you to find and plot the value of S equal P plus Q. So the first thing is you find the values for P, which is -4 plus 3, just reading from the coordinate, and 5 minus I for the Q. Add them together, and here you've got 1 plus 2I as an S, then plot the 1 plus 2I over here. Now the next question is they give you the values of, the quadratic, the polynomial in here, and the A is unknown, but they give you them, it's been divided by x plus 3 and the remainder of 16. Because of the statements in here that I've underlined, that's meaning you will have to use the remainder theorem. Now the remainder theorem says you've got x plus 3 equal 0, and that's x equal minus 3, and then you've got the equation. I've just substituted. It means that I'm going to substitute instead of x -3, and the answer should give me 16. So I've substituted instead of x -3, as you can see in here, and the answer is 16. Then I've used my graphic calculator, just gone into menu, equation, and I've just written it exactly as it is. So if you look at it, it's just exactly as it is. Instead of a, I've written x because there's the unknown. And then after that, you press save and then solve, and give me x equal -6, which means a is -6. Now the next, both those questions are achieved. Now the next question here is this one here. So you've got 5 minus square root of x equals square root of x minus p all squared, and then you want to solve for x. Because x is inside the square root, so I must square both sides. So when you square both sides, that's what you will get. So you're going to write 5 minus square root of x all squared equal x minus p, because the square will eliminate the square root in here. Then I will expand this bit here, so it's 25 minus 10 square root of x minus x equal x minus p. Now I want to solve for x, so I will rearrange, making x is the subject of the formula. So I will have -10 square root of x minus x, that's positive x because it's negative square, and that's minus another x equal -p minus 25. Okay, now those will be simplified. I end up with -10. Got -10 square root of x equal -p minus 25. Again, x is under the square root, so I will have to square both sides to get rid of the square root. So I'll end up with 100x equal -p minus 25 all square. Then x equal -p minus 25 all square over 100. You don't have to extend this one because we've already solved it for x and we've written it in terms of p. Now the next question. Just trying to rearrange it, this one here, so you can, sun doesn't bother you and me. Alright, so the next question here, you've got w equal 1 plus 2i, and you've got this function here, or the expression, and you want to find the answer, and you need the answer as a plus bi. So it's the same as substitution. So you're evaluating, but you're evaluating complex numbers at this time. So we're going to substitute instead of w this one here. So you've got 1 plus 2i all square plus 1 plus 2i over the conjugate of w, which is 1 minus 2i. So now you've got two steps that needs to be done. So you need to expand this bit here, and at the same time you're going to multiply this one here by the conjugate of the denominator, because that's the only way you can simplify complex fractions. So I'm going to expand this one here. I've got 1 plus 4i minus 4 plus, can I multiply this by the conjugate? You can see that I'm multiplying those two brackets and two complex numbers, and they are the same, so it's exactly the same as this one here. So I'm just going to write the answers from here, simplify. So it's 3 plus 4i over multiplying the number by its conjugate. You've got rid of the square, so the I, so you will end up with 1, and I times I is negative, so it's negative 1 times negative 4, so that gives me positive 4. Then now I'm trying to simplify, so I've got 3 negative 3 plus 4i plus negative 3 plus 4i over 5. Now as you're adding two fractions together, so you're going to find the common denominator, which is 5. So I'm going to rewrite that as one fraction, which is 5. Then I'll have to multiply these terms here by 5. Now I'm going to expand, so it's negative 15 plus 20i plus negative 3 plus 4i over 5. Then I will simplify negative 15 with negative 3, that's negative 18. And then positive 2i plus 4i, that's positive 24i over 5. Now because the answer says a plus bi in format, you must split that fraction, so you can rewrite it as this, splitting the fractions. You can write it as this, you can change it into a mixed number, so it's really up to you. And that would be probably a merit question. Okay. The next bit is describing the loci. So the loci of a straight line it's always an excellence question. Okay, depending on how complex it is, but because it does require a lot of algebra, so it's a complex question. That's why it's an excellent level question. Now it's the length, so it's the modular of the difference between two complex numbers equal the modular between the difference between other two complex numbers. So I'm just going to rewrite the z into a general complex number. So I will have x plus yi minus 2 plus 3i equal x plus yi minus 1. Now finding the formula, so that's the real parts together, so that's why we're going to write x minus 2 square plus y plus 3 square all under the square root equal x minus 1 square plus y square and all under the square root. So I'm finding the modular or the length of those complex numbers. Now I have two square roots. The way to get rid of the square root, you square both sides, and that's why you will end up with x plus 2 all square plus y plus 3 all square equal x minus 1 all square plus y square. Now the next step is expanding. So you want to simplify. You can't simplify anything if you don't expand. So we'll end up with x squared plus 4x plus 4 plus y squared plus 6y plus 9 equal x squared minus 2x plus 1 plus y squared. Now cancel out the like terms. If you can't cancel it straight away like this, you could write everything all in one side of the equation and make it equal to 0. So you will have those can be cancelled, those can be cancelled, and because it says straight lines, so definitely you don't need those squares. If you cannot cancel these, that's when you've done something wrong up here. And now I'm going to add the like terms. So I've got 4x minus 2x plus 4 plus 6y plus 9 minus 1 equals 0. And then those two give me 2x. And over here, I've got 13 minus, so it's plus 12 plus 6y equals 0. So to describe it, I know it's a line equation in here, but I can't tell what's the gradient of the line equation, so it's good to write it as y equal mx plus c in this general format. So I'm going to rearrange to rewrite it in here, and that's why I will end up with y equal 2x over 6 plus 12 over 6. If I simplify it, I will end up with y equal 1/3 x plus 6. It means the gradient, I will have a loci is a line with a gradient equal 1/3. And the y-intercept equals 6. That's the final answer. And that's an excellent question. If you've done up to this bit here and you haven't expanded any further, that's give you a merit. If you finish it all but you haven't stated your gradient, and that won't give you an excellence, you must state the gradient. Must gradient. And the y-intercept is just an extra, but you must state the gradient. Now, so we finished question 1. Now the next question. That would do. We'll get rid of this a little bit. Okay. Alright. Now solve x squared minus 6x plus 12 equals 0. You want to find the answer as a plus minus square root of bi. That's mean you will have to use the quadratic formula in this one here. So you've got the quadratic formula equal negative b plus minus square root of b squared minus 4ac over 2a. Now substitute. So that's a, that's b, and that's c. So that's why you will write x. So it's negative b means 6 plus minus b squared is 36 minus 4 times 12 is 48 over 2. Now simplify it even further. That gives you square root of 12i, because it's given me negative 12, and I can't have negative 12 inside the square root. That's why it's square root of 12i. Now you can't leave this as it is. You can leave it at this point here, because this is a, this is b, and I. So that's your final answer in this case. That's achieved questions. Now for that one here, you've got u, you've got v, you've got the v has unknown, and you've been giving the value of u times v equal 22 plus 7i. It means that you must multiply those two numbers together. So you will multiply the 2 plus 3i times 5 plus mi. So you expand it as you're expanding two brackets. So you've got 10 plus 2mi plus 15i minus 3m. Now this one equal 22 plus 7i. Now when you have two complex numbers equal each other, that means the real parts equals together and the imaginary parts equal together. So you can rewrite it as the real parts together and the imaginary parts together. Now you can choose any, both of them should give you the same answer. So I'm going to choose the real parts. So the real component of the imaginary numbers, they are equal. And if I have now an equation as m is unknown, so I'm just going to solve it. So I've got negative 3m equal 12, so m equal negative 4. Now if you substitute that, if you use the imaginary part, you should get the same answer. If you got a different answer, that's mean you've done something wrong in previously. That's again a stupid question. Now the next question is a root question, and that's a merit question, as it's quite straightforward in here. So the root question, remember we find the root of the r value. So the r value is 8k to the power of 6. So you find the third root of ak to the power of 6. I've got negative. That's mean remember that's when you're writing the CIS theta, it means that cos theta plus sine theta I. And because I don't have any value for the sine, I don't have any imaginary parts in here. It means that the I, this bit here is 0, this bit here is negative 1. Then you're going to look into your sine or cosine, or you can actually find that in the calculator as well. But if you look into here, I've got when my angle is 180, it's the sine for that is 0, and for the cosine for that is -1. So it's exactly what I was required. Or you can use in the graphic calculator cosine inverse to -1. It should give you 180 as an answer. It means that I can rewrite that as 180 plus 360k over 3 to find the 3 different solutions. Now you can use pi, so that will be pi plus 2 pi k over 3, so you're going to use radians, or you can use degrees. I'm going to use degrees in my case. So if I simplify that, I will get 2k to the power of 3. So what I'm going to use, you can use the calculators as we've discussed before. So you go to tables, and in the table you're going to, so I'm going to delete all of these, I don't need them. In the table you're going to write the equation as it is, and instead of k you're going to write it as x. So I'm going to write 180 plus 360x close bracket over 3. And when I do that one here, I need to make my range. So I want to start my range 1 to 5. I don't want that. I want to cover negative and positive numbers. I know that I was expecting about 3 solutions. So if I do -3, not -30, -3 to 3, and pitch by 1, you show k is always a whole number. Then pitch by 1, and if I go table now, you can see I can find all the values. So I only allowed to choose the values that's between -180 and +180. So the V's value is -180 when k is equal -2. The second value is the second solution says to -60 when k is -1, and my third solution is says to 60 when k is 0, and that's my 3 different solutions. Okay, now the next question is prove the modular for the division of those two complex numbers equal square root of 10. Because it's a proof, so you know that should give you the answer. That's the answer. Plus, you can't work on both sides together. So you're going to start with the complicated sides, because as this side, I can't simplify it any further. So the way to prove something is you take a side, you're trying to simplify it as much as possible. And if the other side is complicated as well, then you also simplify it as much as possible. And if these two answers are the same, then you've proven your original sides that you've started with are the same. But in this case, square root of 10 is quite simple. So we're going to start with that one here. Because I've got the fraction of 2 complex numbers, then I know that I will have to multiply by the conjugate. Okay, so I know that I need to multiply by the conjugate. So you will go 4 plus 2i over 1 plus I times 1 minus I and 1 minus I. And you can notice I've kept the modular sign still the same because I haven't calculated in modular, I'm just simplifying. So I will expand, I will end up with 4 minus 4i plus 2i plus 2 over 1 plus 1. Then my next step is simplifying the numerator. So I will end up with 4 plus, that is 6, minus 2i over 2. Now simplifying, I will get 2 minus I. And now I can calculate the modular. So the modular for this is square root of 3 squared plus 1. And that gives me square root of 10, and that's proven. Now, the next step here is you find the value of k if this is the equation that's been given. Now, again, I've got roots. I've got square root. I can't do anything if that square root is still the same. So I'm going to rearrange it to having 8 minus x in one side and the other side will have the other square root. Now I can square both sides. If I square this straight away without rearranging, I will continue with this square root because you will have that middle term. But by doing this, that I will know that I will get rid of this square root. So I will square this side here, will give me 64 minus 16x plus x equals square this one here, give me 4, 2x plus k. Now I will expand and rearrange. So minus 15x equal 8x plus 4k. Now keep rearranging. So you said find that they were asking for the value of k. So you've got 64 minus x sorry, I've got x squared in here. I shouldn't have done that. So sorry. The end of the day, I'm quite tired, I guess. So minus 8x minus 4k equals 0. Now I've got a quadratic formula, so I have x squared plus 16x minus 8x, that's plus 8x, and then you will be left with the values for k. So you've got 64 minus 4k. So that will be your A, that's your B, that's your C in the quadratic formula. It says has equal roots, so remember them. This is your quadratic formula, so you've got negative b plus minus square root of b squared minus 4ac over 2a. If the value under the root, which is b squared minus 4ac, equals 0, it means you have one repeated solution. And that's what it means here by equal roots. That's why you're going to use only this formula. So it's not the whole equation. I'm only using this bit here. So I will have b squared as 64 minus 4 times a is 1 times c, which is 64 minus 4k, and that gives me 0. And by solving this equation, I've got only one unknown now, so k, it should give me negative 20. Okay. Right. So you've got this fraction here. You want to write it as, so that's question 3, and you want to write it in form of a plus b square root of c. So again, you've got, so you're going to treat it as kind of complex numbers. So you're going to multiply both numerator and denominator by the conjugate of the denominator. So it will be 5 over 2 plus square root of 3 times 2 minus square root of 3 over 2 minus square root of 3. And now you're trying to start to expand. So you've got 10 minus 5 square root of 3, and this one here, you will expand, you will get 4 minus 3. And 4 minus 3 is 1, so that's why you'll end up with 10 minus 5 square root of 3. That's definitely an achieved question. Now you've got this question here, so you've got b, write the exact value of v over w in polar form. Because we're dealing with polar forms, when you're dividing, we said we're going to minus the bracket, sorry, the thetas. So you've got u over v, so it's 4 over 6, so 3 pi over 4 minus 2 pi over 3. And then you can simplify it further by having this 2 over 3. If you simplify that, cis. And if you don't like fractions a lot, you can always use your magic Quadratic calculator. So you can say 3 over 4 minus 2 over 3. You can see that I've left the pi out because I want to write my answer in pi, in terms of pi. I'm just trying to get your focus right. Okay, so and then by doing this, equal, and you've got 1 over 12, so that's why the answer is 1, which is pi over 12. That's your final answer. And again, it's an achieved question for sure. Now this one here tells you this is the equation that you are working on. This is the value. You've got one solution has been given and you're trying to find the other solution. So because one solution is being given, you will have to think about what can you do to find the other solution. So if you rearrange this one here, you will end up with z minus 3 equal 4 pi. Now if you, so 4i, sorry not pi, 4i, and if you expand, if you square both sides, okay, you will end up with z squared minus 6z plus 9 equal negative 16. Now when you give that one here, you've got z squared plus z6, 6z plus 25, and that's give me to 0. Now why I've done that, I want to see if that's a repeated solution, because z to the power of 3 mean I have 3 different solutions, and this is only one of the solution. So yes, it is a repeated solution, so the other solution must be z minus 2. Why is that? Because I have negative 50 as a constant. With this solution I've got positive 25, so it's definitely I will have to have negative 50, because negative 50 times positive 25 gives me negative 50. Sorry, negative 2 times positive 25 give me negative 50 in here. So that means I can rewrite this as x minus 2, that's one factor, and the other equation is here. Now if I expand this, I will end up with z to the power of 3 minus 8, z squared plus 37z minus 50. I have the b is the coefficient of the z, so that means b is equal to 37. And that's the answer here. Now the next question. I have two complex numbers. Prove that if you multiply them, the conjugate of that is exactly the same when you multiply the conjugate of those complex numbers. So you need to assume that the first number, a plus bi, the v could be c plus di. Now when you multiply them together, so you're going to multiply them together first. So you will have a plus bi multiplied by c plus di. Now multiply them, you will end up with ac plus a di plus bci and minus bd. Okay, now if you make it real parts together and the imaginary parts together. Now you're going to work on the other part of the equations. Now the conjugate of that, it's AC minus BD minus AD plus BC all square. Now we're going to work on the other side together to prove they are equal. So the conjugate of UV, it's A minus BI, and the V conjugate is C minus DI. Now multiplying them together, end up AC minus ADI minus BCI plus So it's minus again because negative times negative is positive and I times I is negative 1. So it's negative BD. Now separate, join them together, the like term, sorry, the equal parts together. So you've got AC minus BD minus AD plus BC I, because there's a common factor as negative, and you can see both of these are equal, so you have proven that they are equal. Now the next bit is UV are two complex numbers such as this, proven that U times V conjugate is purely imaginary. Purely imaginary means only the imaginary part in there. So it's again, you're going to assume that U is A plus BI, V is C plus DI, and then you're going to find first the length of that one here, and the length of that one will be A plus C all square plus B plus D all square, and then if you expand that, you will get A square plus 2AC plus C square plus B square plus 2BD. So I'm just expanding. I'll do exactly the same with that one here, but now it's the opposite. So it's minus A minus C square plus B minus D square. And then now if I expand it, I'll end up with this. Because those two are equal, it means the imaginary part for one is equal to the imaginary part for the other one. So it's give me the real part for one, it's equal the real part for the other one. So that's give me, that's 2AC plus 2BD. It's the same as negative 2AC plus 2BD. Alright? Now, which means that's 4AC plus 4BD equals 0 if you rearrange. Okay? Which give me AC plus BD equals 0 if I keep simplifying. Now I will come to the other part, which is the UV1 V conjugate, and the conjugate for V is C minus DI. Now the C minus DI, if you expand it all, now you expand this one here, you will end up with AC minus ADI plus BCI. I'm just expanding. I'm not really doing anything else beside the expanding, so that's plus. Because I square is negative 1, so that's plus. Now if I rearrange it as imaginary part and real part, so the real part is this, and the imaginary part is that one here. And from here, we've already proven that's 0. So that value is 0. That's why UV dash is equal BC minus ADI, which is purely imaginary. Thank you for watching.